And welcome you in chemistry class. We are studying chapter 4 chemical kinetics. In this video we will discuss about the examples of the first order reactions and their numericals also. Okay, first of all we will discuss about the decay of the radioactive element. It is actually a first order reaction. Decay of radioactive elements, it is a first order reaction. For example, radium, its atomic number is 88 and atomic mass is 226. Okay, decays alpha particles and converted into radon nuclei. Okay, these reactions are of first order reactions and can be denoted by lambda is equal to 2.303 upon T half log N0 upon Nt. Here lambda is replaced by k in first order reaction, or we can say is k is replaced by lambda. Lambda is a decay constant. Okay, T half is the half life span or half life time of the radioactive element. Okay, n0 is the initial number of radioactive particles. Initially, what was the number of the radioactive particles, and nt is the radioactive particles at t time. Okay, means when we in first order reaction we write k is equal to 2.303 upon t log a upon a minus x. Here k is replaced by k, that was the rate constant. It is decay constant. T half is exchanged by T half, and for a here it is n0 and for a minus x it is n t. So it is the rate of reaction for this, and half life time of a radioactive element is same. T half is equal to 0.693 upon lambda. Lambda is decay constant. Okay, for example, C14 is a radioactive element with half lifetime 5730 years. In a sample of wood, 80% C14 is found. Calculate age of sample. It is very important question. Then this process is used to determine the age of fossils or the wood samples or the older samples. Okay, so we know that lambda means 0.693 upon T half. T half is given as 5730 years and NT is 80%. Means 80% particles are present. Means NT is 80%. If N0 is 100, then NT will be 80. Okay, first of all we will calculate the lambda. Lambda will be 0.693 upon 5730. It is 1.21 into 10 to the power minus 4 years inverse. Okay, now we will put the we have to calculate the t means age in this equation. So lambda is calculated and t and n0 is given. So lambda is equal to 2.303 upon t log n0 upon nt, or we can say t is equal to 2.303. Lambda is 1.21 into 10 to the minus 4. Log n0 is 100 and nt is 80. Okay, 0 is 0 cancel. Log 10 is equal to 1. Log 8 means log 2 to the power 3. And log 3 is equal to log, this is equal to 3 log 2. The value of log 2 is 0.3010. So log 8 is 0.9030. On solving is log 10 upon log 8 means log 10 minus log 8 means 1 minus 0.9030. Then the answer will be 0.097. Okay, and then when we calculated, the answer is the 1846 years. Means the age of the wood is 1846 years. Okay, clear? First of all, we have to calculate the value of lambda, and with the help of this lambda, we can calculate the age of the sample. This is here 1846 years. Clear? Second one example is the hydrolysis of ester in acetic medium. Ester means CH3CO C2H5. It is hydrolyzed in the presence of acid, or you can say HCl, and acetic acid and ethanols are present. The reaction takes place in presence of diluted HCl. To study the kinetics of the reaction, a definite volume of reaction mixture is taken out. ठीक है. After definite t time, the reaction mixture is taken out and then it is titrated with the standard NaOH solution, because as we know, on titration the volume of NaOH used is equal to the volume of the acid present in the reaction mixture. Okay, so suppose V0, Vt and V infinity are the volume of NaOH required to neutralize the definite volume of the reaction mixture at t is equal to 0, means initially t is equal to t time and t is equal to infinity time. Okay, suppose when we are starting the equation, the reaction, when we have mixed H plus ions, then suppose 10 ml of the reaction mix is taken out and then titrated with the NaOH, that the volume the which is required to neutralize this 10 ml of the reaction mixture is known as the V0. After 10 minutes, again we taken out the 10 ms. Here acid is increased, volume of acid is increased because acidic acid is formed, so the volume of NaOH is increased. Initially when t is equal to 0, the volume of NaOH represents the volume of HCl only, because there is no any acid in the reactants. Okay, but after t time the acetic acid is increased, HCl is present also, so at t time the volume of NaOH represents the volume of HCl and acetic acid also. So if we subtract the V0 from Vt, then we obtain only the volume of acetic acid. So initially it will be defined by the V infinity, and after V infinity means after a long time, then we assume that reaction is continuously stopped. Then the reaction mixture is taken out and the titrated with the standard NaOH, and the volume of standard NaOH shows the total volume of acetic acid and HCl present in the solution. So their initial concentration A will be taken as V infinity minus V0. V infinity means the total volume of acetic acid plus HCl, and V0 means only HCl, so we can subtract it, and A minus X is directly proportional to V infinity minus Vt. So we can substitute the A and A minus X in the first order reaction. So we can say K1 will be equal to 2.303 upon T log V infinity minus V0 upon V infinity minus Vt. Clear? Okay, this is the initial concentration of ester and this is the concentration at time t, this time t. Okay, next, the inversion of cane sugar. Cane sugar means sucrose. Okay, when sucrose is hydrolyzed, then there is any acid or invertase enzyme is used, and glucose and fructose are obtained. Here it is very important to know that sucrose is a dextrorotatory sugar, means it rotates the PPL into dextro direction, as we have discussed in the stereochemistry already. Glucose is also dextrorotatory, but fructose is levorotatory compound, and this the rotation of PPL by fructose is more than the glucose, so the total rotation is proceed in the negative direction, or we can say in anti-clockwise direction. Okay, so we can study the kinetics of this reaction by the measuring the rotation or the rotation angle of the reaction mixture. Sugar solution is dextrorotatory. Sugar solution means sucrose solution. Glucose is also dextrorotatory, but fructose is levorotatory. The specific rotation of fructose is more than the glucose in opposite directions. Okay. Thus, in beginning, sugar solution is dextrorotatory, but after hydrolysis, the rotation of reaction mixtures changes, which can be measured by the polarimeter. Suppose theta 0, theta t, and theta infinity are the rotations at t is equal to 0 time, t is equal to t time, and t is equal to infinity time. Then initial concentration A will be assumed as the theta 0 minus theta infinity. Here only dextrorotatory rotation is assumed, and here levorotatory rotation will be measured. Okay, A initial concentration is replaced by the theta 0 minus theta infinity, and at t time A minus x will be assumed as the theta t minus theta infinity. So we can replace the values of A and A minus x by the theta 0 minus theta infinity and theta t minus theta infinity. So K1 is equal to 2.303 upon T log theta 0 minus theta infinity in the place of A, and theta T minus theta infinity at the place of A minus X. Clear? Just same as hydrolysis of the ester. Okay. Next is the thermal decomposition of azo-isopropane. It is actually gaseous process. Okay, this is the azo-isopropane. This is a symmetric compound, and on thermal decomposition, it is decomposed into N2 and C6H14 means hexane. Okay, initially only azo-isopropane is present and product is not. So the initial pressure will be P0 of reactant and 0 for the product. But after T time, their P pressure is decreased into N2 and hexane. So there at T time the pressure will be P0 minus P, and pressure of N2 will be P, and pressure of hexane will be also P. So the total pressure at T time Pt will be equal to P0 minus P plus P plus P. Okay, then P and P are cancelled out. So Pt will be equal to P0 plus P. Okay, this is the total pressure, or we have to calculate the value of this. So we want this P, value of P. So we can say here P is equal to Pt minus P0. Okay, P is equal to Pt minus P0. So we can calculate the P0 minus P. P0 minus P. The value of P is Pt minus P0. So P0 minus P is equal to P0 minus the value of P is Pt minus P0. And after solving the bracket, this becomes plus. So 2P0 minus Pt is the value of P0 minus P. Okay. Thus, the first order reaction becomes K1 is equal to 2.303 upon T log. A means P0, initial concentration is replaced by the initial pressure, and the concentration at T time is replaced by the pressure at T time means P0 minus P, and the P value of P0 minus P is equal to 2P0 minus Pt. So it is replaced by the 2P0 minus Pt. It is the first order reaction for the thermal decomposition of the azo-isopropane. Okay, now we see some numerical examples of the first order reactions. Rate constant for a first order reaction is 60-second inverse. What will be the time required in which 1/10 of initial concentration of reactant will be left? Okay, what is given? Given K1 is equal to 60-second inverse, and A minus X is 1/10 of initial concentration. If initial concentration A, then A minus X will be 1 upon 10A or A by 10. So according to first order reaction, K1 is equal to 2.303 upon T log A upon A minus X. We have to calculate the T. So T will be equal to 2.303 upon 60 log A upon A by 10. This is A is cancelled by A, and 10 is, here only log 10 is obtained. 2.303 upon 60 log 10 is 1. So the value will be 2.303 upon 60, or we can say 3.8 into 10 to the power minus 2 second. Means in this time the reaction in reaction only 1/10 part of the initial concentration will be left. Clear? Very simple. Okay, it is clear. Log 10 is equal to 1. I have I want to tell you some special values. These values are, see, log 2 is equal to 0.3010. Log 5 is equal to 0.6990. Log 10 is equal to 1. Okay. See some values here. Yeah. these. Log 3 is equal to 0.4772. Log 1 is equal to 0. Actually, log 1 is equal to 0 because log 1 means log 10 to the power 0. The power is 0, so the value is 0. Log 10 means log 10 to the power 1, the value is 1. Log 100 means log 10 to the power 2, so value is 2. Log 1000 means log 10 to the power 3, and value is 3. Log a to the power b means b log a. Okay, log a upon b means log a minus log b. Log a into b means log a plus log b. And ln e, or we can say log e, will be equal to log base 10 into 2.303. We have to learn these values, log 2, log 3, log 5. Okay, and these values, the formulas of related to logs. Okay, the log 10 is 1, so here log 10 is equal to 1, and we can calculate the time in which the 1/10th part of the initial concentration is decomposed. Next example, a first order reaction has a rate constant 1.15 into 10 to the power minus 3 second inverse. How long time will 5 gram of reactant take to reduce 3 grams? Means initial concentration is 5 gram, A is equal to, and A minus X is equal to 3 gram. Okay, and K is 1.515 into 10 to the minus 3. All things is given, K1, A and A minus X. So we can put the values. T is equal to 2.303 upon K. K is 1.15 into 10 to the minus 3. Log A is 5 and A upon X 3. Okay, so 2.303 into 10 to the power 3 upon 1.15. Log 5 minus log 3. As I have told you, log A upon B is equal to log A minus log B. So log 5 upon 3 means log 5 minus log 3. The value of log 5 is 0.6990 and log 3 is 0.4772. By subtracting, we get 0.2218. And when the procedure is solved here, so by solving this we obtain the 444 seconds. Means in 444 seconds 5 gram reactant will reduce into 3 gram of the reactant in this first order reactions. Clear? Next example, the time required to decompose SO2Cl2 to half of its initial amount is 60 minutes. Means in 60 minutes, half initial concentration is decomposed. Okay, if the decomposition is of first order reaction, then calculate the rate constant of the reaction. We have to calculate the K, and T half is given, this is 60 minutes. As we know that T half is equal to 0.693 upon K1. We have to calculate K1. So K1 will be equal to 0.693 upon 60. It will be 0.0115 minute inverse. Okay. Same next example. Calculate the half-life time of a first order reaction of when its rate constant is 2 minute inverse. Rate constant means K1 is given. T half is equal to 0.0693 upon K1 or 0.693 upon 2. This is 2. So the answer will be 0.3465 or 3.465 into 10 to the power minute. Okay, it is in a minute, so T half is also in a minute. Okay, next. What will be the fraction of a reaction in a first order reaction left after 5 half-life periods? For this, there is a simple formula. A minus X is equal to A 1 upon 2 to the power N. Here N means the number of half-life period. We can also solve this question as after 5 half-life. Suppose this is the initial concentration. 1 half-life, after 2 half-life, 3 half-life, 4 half-life and 5 half-life. There it is 1. Okay, then it will be 1 upon 2 after 1 half-life. Again 1 upon 2. 1 upon 2 into 1 upon 2 means it will be 1 upon 4. Again 1 upon 4 into 1 upon 2 means 1 upon 8. Again 1 upon 8 into 1 upon 2 means 1 upon 16. And last 1 upon 16 into 1 upon 2 means 1 upon 32. It is the one method, one simple method without any formula. How much half lifetime are taken? In we have to calculate, we have to multiply 1 upon 2 by the initial concentration in every half lifetime. Okay, 1 upon 2, 1 upon 2 means after 5 half lifetimes 1 upon 2 initial concentration will remains or will left, or there is some other formula. This is the 1 upon 2 upon n. 1 upon 2, here half lives are 5 means 5 means 1 upon 2 into 2 into 2 into 2 into 2, 1 2 3 4 5 times 2 is multiply. It is also 1 upon 32. 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32. So 1 upon 32 part of A will be left. So in both the forms, 1 upon 2 into the power n, here n is equal to 5, then the fraction of reactant left A minus x upon A will be 1 upon 2 to the power 5 means 1 upon 32. Okay, this is the next example. In first order reaction, some example to prove are also taken. So say for example, prove that the time taken for 99.9% completion of a first order reaction is approximately 10 times of half lifetime. Means we have to prove that T 99.9 means the time taken for 99.9% completion. This is T 99.9 is approximately 10 times of half lifetime, means the ratio of T 99.9 upon T half is equal to approximately 10. We have to prove this. So according to first order reaction, T is equal to 2.303 upon K1 log A upon A minus X. If A is equal to 100, then at T 99.9, A minus X will be 100 minus 99.9, means 99.9% A is converted into product, then the left concentration will be 0.1 only. So A is 100 and A minus X is 0.1. We can put the values. T 99.9 is equal to 2.303 upon K1 log 100 upon 0.1, or this is cancelled by increasing the 1 0. So T 99.9 is equal to 2.303 upon log K1. K1 log 1000. Log 1000 means, I have told you, log 1000 means log 10 to the power 3. Then the value will be 3. So it is multiplied by 3. 2.303 into 3 upon K1. So the answer will be T 99.9 is equal to 6.909 upon K1. This is the equation number 1, but we know that the half life of first order reactions T half is equal to 0.693 upon K1. It is already proved. Okay, so now we divide the equation number 1 by equation number 2 to obtain the ratio of T 99.9 upon T half. So it will be 6.909 upon K1 upon 0.693 upon K1. K1 is cancelled by K1. 6.909 upon 0.693, it will be approximate equal to 10. It is proved. Thus we can prove the ratio of any two times. Okay, for example, one more example here. See, prove that the time taken for 99.9% completion of first order reaction is approximately 2 times of time taken for 90% completion. Okay, we have to learn that always we assume that A is equal to 100. If 50% reaction is completed, then A minus X will be 100 minus 50 means 50. If 75% reaction is complete, then A minus X will be equal to 100 minus 75 means 25. If 87.5% is completed reaction, then A minus X will be equal to 100 minus 87.5 means 12.5. If 90% reaction is complete, then A minus X will be equal to 100 minus 90 means 100. If 97.93.2% reaction is complete, then A minus X will be equal to 100 minus 93.25 is equal to 6.75. If 99.9% reaction is completed, then A minus X will be equal to 100 minus 99.9 is equal to 0.1. If 99% reaction is completed, then A minus X will be equal to 100 minus 99 means 1. Okay, we have to assume these values. How much reaction is completed, then according to this percentage we can calculate the value of A minus X, and A always will be taken as 100. Okay, so in this reaction also at T99, A minus X will be 100 minus 99 is equal to 1. And at T90, A minus X will be equal to 100 minus 90, that will be equal to 10 when A is equal to 0. Then we have the value of first order reaction for T99. T99 will be equal to 2.303 upon K log 100 upon 1. Okay, or we can say log 100 means log 2 minus log 1 means 0 means 2 only, then T99 will be equal to 2.303 into 2 upon K1. And for T90 will be equal to 2.303 upon K log 100 upon 10. Okay, 100 upon 10 means 0 is cancelled by 0. Here only log 10 will be remain. Log 10 means 1. Then T90 will be equal to 2.303 upon K only. So, the ratio of T99 upon T90 will be equal to 2.303 into 2 upon K1 upon 2.303 upon K1. Okay, it is the value of T90 and it is the value of T99. These are cancelled, so it will be equal to 2. It is proved. It is 2 times of time taken by 90% completion. So thus in this way we can calculate many types of relation. See, some important relations are T infinity is equal to 100 infinity always. T75 will be equal to 2 into T half, means the time to completion for 75% reaction will be double or 2 times of its half-life. 87.5 T will be equal to 3 into T half. T93.75 will be equal to 4 into T half. T99.9 will be equal to 10 into T half as we have proved. T99.9 will be equal to 3 into T90. T99 is equal to 2 into T90. It is also proved. These are the values I have told you. Log 2 is equal to 0.3010 and these are also. I think you can understand the examples of first order reaction and related their examples, numericals also. Thank you.